Good afternoon, 6th grade class. This afternoon we will be working on learning about the greatest common factor. Now earlier in class we learned about what a factor is. A factor is a whole number that divides a non-whole number with a remainder of 0. So for example, the factors of 20 are 1, 2, 4, 5, 10, and 20 because 1 times 20 is 20, 2 times 10 is 20, and 4 times 5 is 20. A common factor is a factor that two or more numbers share. So the factors of 12, as we talked about in class, are 1, 2, 3, 4, 6, and 12. And the factors of 20 are 1, 2, 4, 5, 10, and 20. Now, we need to find the ones that are in common, ones that they have alike. So they both have a 1. So that would be a common factor. They also both have a 2. So that would be another common factor. They both have a 4. So that would be a common factor. 3, 5, 6, 10, 12, and 20 are not common factors because they don't both have them. Now, the focus of today's lesson is on the greatest common factor. It's the greatest factor shared by two or more numbers. So we want to find the greatest common factor of 20 and 35 by making a list. So as we learned, to find the factors, it's on the boxes on your graph paper that you used in class today. How many different ways can you make 20 where the sides of the squares match or line up? So we know for 20 we have 1 and 20, because 1 times 20 is 20. We have 2 and 10. 3 is not. We have 4 and 5. Those are my factors of 20. Now I need to look for my factors of 35. So I have 1 and 35. 2, no, 2 does not go in because it's an odd number. 3, nope. 4, nope. 5. 5 times 7 is, 5 and 7 are factors of 35 because 5 times 7 is 35. Now I can't go any further. These are all the factors. Now my goal is to find the one that is the greatest. So I see that both of them have a 1, but there might be one that's bigger than 1 that they both have in common. So I'm going to circle all of the ones that they have in common. 1 and 1 and 5 and 5. Now I know because I know that 5 is bigger than 1. So 5 would be the greatest common factor of 20 and 35. Now we're going to try a different way to find the greatest common factor. This is using a division ladder. So I have 42 and 56. Could put the numbers side by side and make an upside down division symbol. What number goes evenly into both 42 and 56? Well, I see that both numbers are even, so I know that 2 goes into both of those numbers. 42 divided by 2 is 21. 56 divided by 2 is 27. Now, are those prime numbers yet? Can I go further down? I can go further. They are not prime numbers, so I'm going to put a second upside down division sign and figure out what number goes into both 21 and 27 evenly. Well, 3 does. 3 goes into 21 and 27 evenly without a remainder. 21 divided by 3 is 7. 27 divided by 3 is 9. Now, is there any number that goes into both of these numbers, both 7 and 9, evenly? There is not. So what I need to do now in order to find the greatest common factor is I need to look at the two common factors. They both have 2 and they both have 3. these two numbers right here. Then I need to multiply them together. So 2 times 3 equals 6. So my greatest common factor of 42 and 56 is 6. I'm going to do one more using a division ladder. Greatest common factor of 24 and 54. Upside down division symbol. They're both even, so I know that 2 can go into both of them. 24 divided by 2 is 12. 54 divided by 2 is 27. Now, can anything go into both of those? It can. 3 can go into both of those. And again, we're looking for simple numbers. Simple like 2s and 3s. 3 times what number is 12? 4. 27 divided by 3 is 9. Can any number go into both 4 and 9 evenly? It cannot. So again, I take my two common factors, which are 2 and 3, and multiply them together. 2 times 3 equals 6. So the greatest common factor of 24 and 54 is 6. Now I'm going to use factor trees. Now factor trees we did learn a little bit in class today. But in order to find the greatest common factor using a factor tree, we need to make the factor trees. Starting with 27. What times what equals 27? And like we did in class, we're thinking easy numbers. 3 times 9 is 27. 3 is a prime number, so I'm going to circle that. 9 is not a prime number. It is a composite number, so I'm going to break that down further. What times what is 9? Well, 3 times 3 is 9. Again, I ran into prime numbers, so I'm going to circle them, and that is the end of 27. Now 36. What times what is 36? 3 times 12 is 36. Circle the prime number. 3 times 4 is 12, and 3 is a prime number, so I'm circling it. 4 is not a prime number because 2 times 2 is 4. Now 2 is a prime number, so I'm going to circle those together. Now, we're not done. We need to find the greatest common factor, so I'm going to list the factors of 27 and 30, the prime factorization of 27 and 36. So for 27, I have 3 times 3 times 3. This 3, and that 3. Then for 36, I have 3 times 3 times 2 times 2. Now, I need to find the ones that they have in common. I see that they both have a 3, and they both have another 3. That's all they have in common. This one has a 3 and this one has 2's. They don't have that alike. I need to take now, this is where it could get a little confusing, but just pay very close attention. I have one group of 3's, so I'm going to write 3 right there. I have another group of 3's, so I'm going to write that right there and multiply them together. 3 times 3 is 9, so the greatest common factor of 27 and 36 is 9. I'm going to do one more really quickly, just to make sure you guys understand it. So we have 12 and 32. Prime factorization of 12, I have 3 and 4. 3 is a prime number, 4 is not. 2 times 2 is 4, and 2 and 2 are prime numbers. 32, I have 2 times 16. 2 is a prime number. 16 is a composite number. What times what is 16? Well, 4 times 4 is 16. 4 is not a prime number. It is a composite, so let's go further down. 2 times 2 on both of them, just like this. And 2 is a prime number. So my prime factors of 12 are 2 times 2 times 3. My prime factors of 32 are 2 times 2 times 2. 1, 2, 3, 4, 5. There's 5 of them. 1, 2, 3, 4, 5. I'm going to circle the pairs. Leave the rest alone. There's a set of 2 and another set of 2, so I need to multiply those together. Get 4. So my prime factorization, or my greatest common factor of 12 and 32 using factor trees is 4. Now it's your turn. In your textbook, please turn to page 129 and 130. On those pages, please complete numbers 1 through 3, 7 through 9, and 13 through 15. Make sure you do your best. Look back in the video if you have questions, and bring additional questions to class tomorrow. Thank you very much, and I hope you have a fantastic evening. Have a good night.